So today's lesson is on the quotient rule. Okay. Now this is a little. You see above here. This is a little proof of the quotient rule. The quotient rule is this. This is the key part which you really need to know. Which is dy by dx is equal to 1 over v squared bracket v du by dx minus u dv by dx. Now, we're using the quotient rule. The quotient means division. So when we're doing, this is for doing differentiation, when we're doing things that we need to divide. So we will do an example of this in a little second. And the u is always the top. In fact, it's probably worth writing that actually. So it's when they're in the format y is equal to u over v, like so. Okay. So yeah, the way that they've got like this little memorized tip down here, which says you always do the bottom first. It's always 1 over v du by dx minus u minus u dv. So that's the best way to remember it, because you're doing that division, the 1 over v du. Try and remember that the fact that it's 1 over. Oh, sorry, I've made a mistake there. It's actually 1 over v squared. That should be 1 over v squared v du minus u dv. Okay, so moving on from this, let's have a little look at this question here. So this question here says, if y is equal to x over 2x plus 5, find dy by dx. So the way that we do this is, the first thing we'd do is we'd say what u and v are. Now u is always the top, so u in this case is equal to x, and v in the is the bottom of this, so v in this case is equal to 2x plus 5, like so. Now, you'll notice in this formula that we were using, so this one here, it's probably worth writing this down. So this here, probably worth writing this down at the bottom. So, in fact, we've got not much space over here. I'm going to do this on just on the on the right hand side over here. So, we know that the formula is equal to dy by dx is equal to 1 over v squared v du by dx minus u dv by dx, like so. So we just wrote down what u is, we just wrote down what v is. What the other things that we need in this are the du by dx and dv by dx. So let's write down what they are first. So du by dx means we're differentiating u with respect to x. Now this part over here is the u over here. So if we differentiate this with respect to x, we're going to get, well, the differential of x is going to be equal to 1, there, like so. And dv by dx, which we're going to also need, so dv by dx is equal to, well, if we differentiate this part here, which is the 2x plus 5, we're going to get 2 for this one here. Okay? So u differentiates to 1, and 2x plus 5 differentiates to just 2. So now we're going to sub all this in. So dy by dx is equal to 1 over v squared. Now v is that 2x plus 5, so it's going to be 1 over 2x plus 5 all squared, like so, times by v du. Now v is that 2x plus 5, so we need, that's going to be the same again. So 2x plus 5 times by du, which was the 1. I'm going to put that there just for this first one, just so we know it, minus u dv. Now u is that x, so minus x times by dv by dx, which is equal to the 2. So we're just subbing in all those values. The hardest part about this is that first part of the differentiation, and then sometimes simplifying as well. So yeah, let's simplify this now. So dy by dx is equal to, well, let's simplify this top. It's going to be 2x plus 5 times by 1, which is just going to be 2x plus 5, minus 2x. We're just going to get, in fact, I will write this out again just so that we can see it. So it's going to be 2x plus the 5 minus 2x all over 2x plus 5 all squared, which is equal to, well, 2x minus 2x is equal to 0, so you're just going to end up with 5 on the top all over 2x plus the 5 all squared. And that's it. So this here is what we're looking for. dy by dx is equal to 5 over 2x plus 5 all squared. So this next one here says find the stationary points. Now, straight away when I'm thinking stationary points, I'm thinking about dy by dx, because we know stationary points are when dy by dx is equal to 0. So the thing that we need to notice here is the fact that we've got the thing that we've noticed is that we've got sin x over e to the x plus 2. So we need to use the quotient rule here. And the quotient rule is going to be, well, the top is going to be u. So u is equal to that sin x. V is equal to e to the 2x. So then du by dx, which is the first thing we're going to have to find out. So du by dx, remember this is the new part, isn't it? Because we're differentiating a trigonometric one here. And then when we differentiate this one, the one we need to think about is this, where it's the sine, which differentiates the cos, which differentiates the minus sign, which differentiates the minus cos this way around, like so, when we're differentiating. So with this one here, remember that. So du by dx differentiates to cos of x. And then dv by dx differentiates to, well, this is where we're going to have to use the chain rule. So e to the anything differentiates to e to the something. But inside there, you've also got the 2x. It's like those two layers, isn't it? So this one here is going to differentiate to, well, the e to the 2x differentiates to e to the 2x. I differentiate inside that function, which is the 2x, and times by that. So the differential of 2x is 2. So it's going to be 2e to the 2x. Haven't finished there yet, because I now need to sub all this in. So dy by dx is equal to 1 over v squared. This is going to be 1 over e to the 2x all squared, which is equal to, oops, not equal to, my fault. E to the 2x times by, let's move that down a little bit. So e to the, I should have wrote down the formula first, shouldn't I? Because just to make sure that you understand it, I'll write that down over here. So the formula is dy by dx is equal to 1 over v squared times by v du by dx minus u dv by dx, like so. So I've stubbed in, let's just show that this is what's going to be over here. So 1 over v squared, which is this e to the 2x all squared, times by v, which is e to the 2x, so e to the 2x, times by du by dx, which is equal to that cos x, like so, minus u, which is the sine x. I'm just going to put in a bracket some times in by that, so sine of x, times by dv by dx, which is equal to that e to the 2x, like so. Loads going on here. So we now need to simplify all of that. So this is going to be equal to, this is equal to, I'm going to keep that as a squared for now, because I'm going to take out a e to the 2x in a second. In fact, I can probably take that out now, can't I? It's going to be, let's take e to the 2x out as a common. So you can see here, we've got this e to the 2x there, and we've also got an e to the 2x there that we can take out as a common factor. So when we do this, it's going to be e to the 2x times by, well, on what's left over there is that cos of x. So cos of x minus what's left over here is that sine of x. So minus sine of x all over the e to the 2x all squared, like so. So then the reason I've left this as a squared is because I can see that I've got an e to the 2x. Yes, it is 2e to the 2x, isn't it? Which one should be 2e to the 2x? The dv by dx, which is the second one here. So there should be a 2 in front of that sign there, shouldn't there? So this here this should be 2e to the 2x. Two e to the 2x there, which means when I take this out here, this here should have been 2 sine x there. Like so. And then I can cancel then I can think about the top and bottom here, which is the e to the 2x there is going to cancel with one of these e to the 2x's on the bottom there, like so. So I'm just left with dy by dx is equal to cos of x minus 2 sine of x all over e to the 2x, like so. Now, we've still not finished this because the whole point of this question is asking us to find the stationary point of this, which is where this becomes a little bit of an extra question. So I'm just going to take all of that there. I'm just going to make this smaller, just so I've got enough room. We know that we have a stationary point when dy by dx is equal to 0. We know that. So what we're doing here is we're setting this equal to 0. So 0 is equal to cos of x minus 2 sine x all over the e to the 2x there, like so. Now I'm going to times both sides by e to the 2x. That's just going to leave me with 0 is equal to cos of x minus 2 sine of x. Take that sine x over, which is going to give me 2 sine. In fact, I probably should have left the sine x on that. Doesn't matter. I'll take it over in a second. 2 sine of x is equal to cos of x. And then I'm going to divide the right-hand side by 2. I'm going to divide the left-hand side by cos, which is going to give me, if I divide the left-hand side by cos, I'm going to end up with sine of x over cos of x is equal to a half, which gives me my final little part, which is that tan of x is equal to a half. Now, this is what I'm going to have to solve. So, let's solve this over here. So remember, we're going to have to find our acute angle first. So my acute x is going to be equal to tan to the minus 1 of a positive half. Let's do that on our calculator. Shift tan to the minus 1 of 0.5, which is equal to 29.5 degrees, like so. 29.5 degrees. Now, we're then going to draw our cast diagram. C, A, what am I doing today? C, A, S, and T. And then because it's because tan is positive, we know that it's going to be in, yeah, it does need to be in radians. We know that it's going to be in, I'm just going to change my mode. shift tan to the minus 1, 0.5 is equal to 0.36. Can we get rid of that there? .464. So yeah, because we're in tan, we know we're going to be in this section here, and we're also going to be in this section here. So this is going to be equal to the 0.464. This part here is also going to be equal to 0.464. Well, this is 0 and 2 pi all the way around, and this one here is pi. So the two that we're going to have are x is equal to, this naught is just going to be that one there, isn't it? 0.464, or it's going to be pi plus that. But does it want it just between that and pi, which means it's going to be, that one doesn't count. So it's just going to be these two here, which gives you this as your final answer. Because we want the stationary point, we have to sub that back in as well. Woof. So we've got our x value. The last thing we need to do is to sub it in to find our y value. So our y value is going to be y is equal to, well, we know our x is equal to the 0.46. So it's going to be sine of 0.464 all over e to the 2 times by 0.464. So on our calculator, that's going to be, fraction button, sine of 0.464 all over shift e alpha e to the power of 2 times by 0.464, which is going to give you y is equal to 0.177. So our coordinate, last little point, is going to be 0.464, comma 0.177. Loads going on there. It's quite a big, long question. The key part to this is this beginning bit, isn't it? Which is where we need to think about our quotient rule here. This is the key part. Okay, that's what we need to remember. And then we need to differentiate u, which is going to be this part here. And then we need to differentiate v, which is going to be this part here. And then once we've done all of that, we're all good. So pause now and have a little go at these to yourself. Have a little go at these to yourself. Okay, so pop your hand up if you got that right. Everybody happy with that? Good, 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 good. Good. So let's have a look at this bottom one here then. So I just want to make sure this is right. Let's just get a line under there. So I'm not quite sure with this one here. This one isn't quotient, is it? I think this is just the normal one, this second one underneath. Carrying on from what we did yesterday. So you just want to check that. Is that x e to the x? Yeah, it is, yeah. So we have y is equal to e to the... I would have probably put the root 3 in front of it, but I can see why they haven't done that, because they don't want you to think it's under there. So it's going to be x root 3 times by sine of 3x. And what they're saying here to do is they need you to find the x-coordinate of the turning point on C. Give your answer as a multiple of pi. So straight away, if I'm thinking turning point, I'm thinking dy by dx. Now with this one here, I've got two things which are multiplied together by each other. So we're going to be using the product rule. So in this one here, u is equal to e to the x root 3. And v is equal to sine of 3x. So du by dx is going to be equal to... Now, if I differentiate e to the x to the root 3, you're just going to be left with e to the x root 3. But don't forget you need to differentiate inside that. And anything that they've switched it around there and they've kind of confused you a little bit. But actually, this here should be root 3 e to the x root 3. Because when you differentiate, if I was to differentiate 2x, I'd just get 2. If I was to differentiate root 3x, I'd get just the root 3. So that's the part there. I'm just going to put a line here. You can see that that's a different part of that. And then dv by dx is equal to... Now, if I differentiate sine, I'm going to get cos of 3x. And then I differentiate inside that and multiply that. So it's going to be 3 cos of 3x. Then we're subbing into the formula. Now, the product rule formula is dy by dx is equal to u dv by dx plus v du by dx. In this case, u is equal to that e to the x root 3 or 3 root x times by dv, which is 3 cos of 3x, like so, plus the v, which is the sine of 3x, so sine of 3x times by du by dx, which is the root 3 e to the x times by root 3. Woof. So I can probably simplify this. Let's simplify that then. which is going to be, take out e to the power of x root 3. So e to the power of x root 3 times by, what am I left with here? I'm left with 3 cos of 3x plus, now I've taken out the e to the x root 3, but I've not taken out that root 3, so it's going to be plus root 3 sine of 3x. So this is what dy by dx is equal to. So dy by dx is equal to this. So then we know that if we want to find the turning point for this, we know that our turning point is when dy by dx is equal to 0. So we need to set this equal to 0. So we're going to have 0 is equal to e to the x root 3 times by 3 cos of 3x plus root 3 sine of 3x there, like so. So we're going to get two solutions to this because it's equal to 0. Either the e to the x root 3 is equal to 0, which is impossible. Can't have that. So we're just left with this part here, which is the zero is equal to 3 cos of 3x plus root 3 sine of 3x, like so. So give myself some more space. Where am I now? So let's take the cos over to the other side. Yeah, so it's going to be minus 3 cos of 3x is equal to root 3 sine of 3x, like so. And I'm going to divide the right-hand side by cos, divide the left-hand side by that root 3. So I end up with minus 3 over root 3 is equal to sine of 3x over cos of 3x, which is going to give you, now I'm just going to switch those over to the other side. It doesn't make too much difference. Tan of 3x is equal to minus 3 over the root 3. So I'm going to have to find my acute angle for that, which is going to be my acute 3x has to be in radians, doesn't it? My acute 3x is going to be equal to tan to the minus 1 of the positive value of this, which is 3 over root 3, like so. So let's just work that out. Shift tan to the minus 1 of brackets 3 over, not to the power, root 3 in radians, which is going to give me my acute 3x is equal to 1.05 it is. I'm just going to take this up here now. So we're now going to have to draw our cast diagram. So C, A, S, and T. Now remember that this is going to be a negative tan, so that's going to be in sine and in cos. We've got 0, pi, 2 pi, and this is the angle here which is going to make. So this is such a long question, isn't it? So we also have to think about our boundary as well. I'll think about that in a little second. So we end up with that 3x is equal to pi minus 1.05. So shift pi minus 1.05, which is equal to 2.09. But you're also going to have 2 pi, so all the way around there, minus that 1.05. So remember, this here is 1.05. This here is 1.05. Okay? So 2 pi shift pi minus 1.05 is equal to 5.23 for that one. Remember, these are in radians. So we've also got to be careful with the fact that this is the boundary here. So if you look at our boundary for this one, our boundary is this, isn't it? So if we want our boundary for this, we're going to have to times this by 3x, which is going to give us minus pi is less than or equal to 3x is less than or equal to pi. So times all of those by there by pi. Now pi is equal to 3.14. The one that I'm worried about is the fact, well, this is here definitely doesn't work because it's outside of 3.14. But what I want to think about is there another one inside that if I subtract this from here. And I've also just realized they said they want it in terms of pi, which is really annoying. Let's just do that again. So shift tan to the minus 1 of 3 over root 3, which is actually equal to here. I should have wrote this as pi over 3. So when I do this, it's going to be 3x is equal to pi minus pi over 3. So shift pi minus shift pi over 3, which is going to be equal to this first one in pi is equal to 2 over 3 pi. This one here would have been 2 pi minus that, which is equal to 5 pi over 3. But again, we can't use that one. But what I do want to think about is if I subtract 2 pi from this, does that give me something which is inside that range there? So minus 2 pi from this one. So minus 2 shift pi which is equal to this. So yes, we end up with 3x is equal to minus pi over 3 and 2 over 3 pi. So yes, both of those are in our limit. So now we need to divide both sides by 3. So x is equal to this, which is going to be minus pi over 9, and this one here, which is going to be 2 over 9 pi, like so. Just going to check that before I carry on. That's 6 marks. That's a lot of big marks there. Where are we? So 2 pi. Yeah, there it is. 2 pi over 9. Now, just thinking about this, both of those answers are right, but don't forget that they're asking for the coordinate of P. Now, I've actually found 2 coordinates here, and the coordinates I've found are this part here, which is going to be this minus pi over 9, but this is the one that they want, and this is the 2 over 9 pi, which is there. So actually, I still haven't finished this, have I? Because they said it's just the x coordinate I want. So the x coordinate would be the to this one here. Super. So we've still not finished this, have we? Because it's asking for the equation of the line for this one, which is part B. And this part isn't quite as tricky. So part B for this says find the equation of the normal. Now you need to be really careful with that because it's the equation of the normal, not the tangent. So we know that the equation for we know that the gradient formula is this dy by dx, which is over here. So this here is the dy by dx. So we've got dy by dx is equal to e to the x root 3 times by 3 cos of 3x plus root 3 sine of 3x, there, like so. And I'm subbing in our x coordinate for this, which is 2 over 9 pi. So if I sub this in, dy by dx, now remember this is just exactly the same as what we were doing normally, it's just we've got all these horrible e's and x and cos's in. So it's going to be e to the 2 over 9 pi times by root 3 times by 3 cos of 3 times by 2 over 9 pi, like so, plus root 3 sine of 3 times by 2 over 9 pi. Look at all of that there. So I would just put all of that straight into our calculator. Okay. So let's put that into our calculator. So alpha e to the power of, open bracket, 2/9 times by shift pi, close brackets, times by √3, close brackets, like so. Open bracket, 3 cos of, open bracket, 3 times by, fraction button, 2/9 of pi, close bracket, plus shift, no, not shift, √3, yeah. Ah, right, okay, sorry. Point in where x is equal to 0, sorry. So, yeah, thank you. Not at the line, because obviously the line there, so just have to change some of this. So it's not that much of a difference, it's just that instead of summing in my value now, this x is not equal to 2/9 pi, it's equal to 0. Thank you for that. Which does tidy things up a little, actually, doesn't it? Because e to the power of 0 is going to be equal to 1. Cos of 0 is also 1. So that's going to be 3 times by 1 there, like so. Plus sine times by sine of 0 is going to be 0. So plus 0 for that one, which is just going to leave me with dy by x is equal to 3, is it? Done that in my head. I probably should have done it straight on my calculator. Still not finished there, because that's the tangent, don't forget. And actually we want the normal. So the normal is going to be the negative reciprocal of this, which is going to be equal to -1/3. Let me just check that there. When x is equal to 0, what is y equal to? Well, y is equal to 0 as well. So in which case, we have actually finished this. It's not actually as hard at first thought, because we end up with, we're subbing in the value x is equal to, x is 0, 0. And my gradient, which I've just found out, is -1/3. So when I sub this in, my c value we already know is going to be equal to 0. So it's going to be y is equal to a -3rd x, like so. Brilliant. Loads going on there. Lots and lots going on. Let's just check that. Yeah, -1/3 x. Good. It is tricky, that. It is tricky, that. So we've just had a go at those two. We're now going to have a look at taking just that a little bit further, and we're going to look at differentiating trigonometric values now. Okay? So to do this, what we use is, there are lots of formulas for this. Yeah, there are loads of formulas which you'll need to know for this, and you're not expected to know all of these. Some of them you're expected to prove. So, for example, to differentiate a differential tan, sometimes they ask you to prove that, but the majority of them, you're actually given, and you need to use them. Okay, so let's have a look at this top one here, which we again can do. So if I'm doing the differential of tan, well, we know that we can write tan is y is equal to sine of x over cos of x. We know that. Like so. So in this case, we know that u is equal to sine of x, and that v is equal to cos of x. So we know that du by dx is equal to cos of x, and dv by dx, well, what does cos differentiate to? Remember, we've got this little here, sine cos, minus cos. Cos is going to differentiate to minus sine of x, like so. And then we're going to sub it into our formula, which is 1 over v squared times by v du by dx minus u dv by dx, which is equal to 1 over v squared, which is going to be cos, so cos squared of x, times by v, which is cos, du, which is cos, v du, yeah, good. So that's going to be cos squared as well, isn't it? Minus u, which is sine of x, minus u, which is going to make it plus, so it's going to be plus sine squared of x, okay? And we know that, we should probably just put up here dy by dx. And we know that this is equal to, we know that this part here is equal to 1, don't we? Because cos squared plus sine squared is equal to 1. So we know that this is equal to 1 over cos squared x. And what is 1 over cos? Well, we know that 1 over cos is sec, isn't it? So this is equal to sec squared x, which gives you the differential of tan x with respect to x is equal to sec x. And that's a nice little proof there, just to show that. And down here at the bottom as well, we've got this 1 over sec x. We can do exactly the same with this. Okay, so we can say that this is equal to, well, sec is equal to 1 over cos, isn't it? So if I say that u is equal to 1 and v is equal to cos of x, then I can say du by dx is equal to 1 and dv by dx is going to be equal to minus sine of x. So we then end up with 1 over v squared, which is going to be the 1 over cos squared x times by v du by dx, which is going to be cos of x, minus u, so that's going to be plus a sine. Just check that I'm getting this right. Yeah, sorry, this one here, I knew there was a mistake there somewhere, silly Billy. If I differentiate u, it's not 1, is it? It's going to be equal to 0 there. So v times b du by dx, v du is going to be that times by 0 times by sine times by 1, which is plus sine. So I'm just going to take this here like so, which is going to be sine of x all over cos squared x. Which actually can be split into this part here, and I'll show you how we're doing that. If I write sine, we'll just take this over to the here. If I write this as sine of x over cos of x times by 1 over cos of x, we can see that that's the same as this part over here, can't we? And we can write this. We know that sine over cos is equal to tan of x. And we also know that 1 over cos is the sec, which we were talking about before, which gives us this here. The differential of sec is equal to k sec kx times by tan kx, which is what I've just proved there. All right. Just pop your hands up if you're happy with that. Good, good, good. All right. So I know this is tricky. Have a little go at this one yourself. This one here is from a past paper. He's trying to find out what that constant is. So they're asking you to simplify it. So have a little go at that one yourself. Okay, so I'm going to start having a little go at this. So the first thing I'd probably do is to write down this as sec of 3x all squared. That's the first thing I'd probably do. Because then when I differentiate this, excuse me, I need to do that 2 first. So it's going to be 2 times by, because you've got 3 layers here. You've got that squared, then you're going to have to differentiate the sec, then you're going to have to differentiate the 3x. So if I differentiate the sec first, I end up with 2 sec of 3x times by, if I differentiate sec x using our notes before, I get sec x tan x. So times by sec of 3x tan of 3x. Last part, I need to differentiate inside of that, which is going to be times by the 3. So I end up with 6 times by sec squared times by 3x tan of 3x. However, they don't want it. Notice here that all of this is in terms of tan. Okay? And we know that there's a formula that links sec squared and tan, which is... Should have all my notes here. Should have my formula book, shouldn't I? I'm going to write it. I always like to prove it anyway. So sine squared of x plus cos squared of x is equal to 1. To get tan, I need to divide by cos. So I end up with tan squared x plus 1 is equal to sec squared x. Cheers, Sam. So this one here, I need to substitute in here. So it's going to be equal to 6 tan of 3x times by sec is equal to tan squared plus 1. So tan squared x plus 1, which gives us... I should probably switch these. I'll do that in a second. 6 tan cubed of x plus tan of x, which is equal to... Switch those round. Sorry, 6 times by that. So this needs to be 6 tan there, doesn't it? Which... And these should all be 3 as well. Which gives us 6 tan of 3x plus tan cubed of 3x. There, like so. There we go. So in which case we know that mu is equal to 6. All right, so let's have a little look at this then. There's that.